Okay, so we're doing 5.5, real numbers and their properties. So we've talked about different sets of numbers before, and now we're just going to talk about them again. So we have three sets of numbers: the natural numbers, whole numbers, and integers, and we've talked about them before. So the natural numbers are just all the positive integers. And if you think of sheep, they're all whole sheep. I can have 1 sheep, 2 sheep, 3 sheep, but they're alive and they're whole. When we go to whole numbers, it's all the positive integers plus 0. I can have 1 sheep, 2 sheep, 3 sheep, and they're all alive. Okay? Integers are all the positive integers, the 0, and the negative integers. I can have 1 sheep, 2 sheep, 3 sheep. I can owe my brother 4 sheep, and they're alive. If you've seen these nesting dolls before, these Russian nesting dolls, you can think of the natural numbers as the smallest one, and this one fits inside this one, and then this one fits inside this one, and then this doll fits inside that doll. When we get to the rational numbers, that's where we have 3.5 sheep. That's like dinner. We have 3 sheep and half a sheep. Okay, the sheep is not whole. It's not alive anymore. Okay, so we have our positive integers here, plus we have some decimals, we have fractions. So here you can see we have 2 sheep and a little bit. Okay, maybe I owe someone 2 sheep. So rational numbers are all the numbers that we can write as a ratio of 2 integers. And what does that mean? It just means we can make a fraction. All these numbers here can be made into a fraction, or a ratio of 2 integers. Any decimal that repeats, that's also can be made into a fraction. And any decimal that stops or terminates can be made into a fraction. So all of these are rational numbers. Then we have irrational numbers. Anything that's crazy. Okay? So here, anything that goes on forever and ever and ever and ever, okay? Non-terminating means non-stopping, okay? So non-stopping, okay? Non-repeating, so it has to have nothing that looks nice, nothing that repeats. If it's repeating, it's over here. So it goes on forever and ever and ever. So you'll have these dots, okay? But be careful with pi, because oftentimes we remember pi as 3.14, but it's not just 3.14, it's 3.1415, blah, 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 okay? So anything that looks crazy is over here. This is just another way to look at the sets, if you need another way to help you understand them. Okay, so let's go to the next page. So here we just have all the positive integers. So it says write the name for each group of numbers. You can use the words more than once. So these are my positive integers. Oops, you can't see that. Write the name for each group of numbers. You can use the words more than once. So these are positive integers, and we call them natural numbers. Natural. They're the ones we teach children to count with when they're little. So here we have the positive integers. Here, oops, that's not a positive integer. Let's do that again. So here we have the positive integers, we have the negative integers, and we have 0. So when we have all 3, we call them the integers. And this G is pronounced J as in Jassim. Okay? Integers, not gers. Integers. So here I have all the positive integers plus 0. That means those are the whole numbers. Because remember, if you have the 0, it's whole. Now we have things that have fractions. They're not whole sheep. They're not whole numbers like integers. But they're kind of nice. They can be made into fractions, they terminate or stop, or they repeat. So when I have decimals that look nice, or things that can be made into fractions, they're called rational numbers. Rational numbers. Now these ones here, these ones go, this should have dot, dot, dot here. They go on forever and ever and ever. And remember, pi goes on forever and ever. Let's look at root 5. Root 5, there's nothing repeating. It doesn't stop. It only stops because the calculator screen is small, but really it goes on forever and ever and ever. So these are irrational, which, like this, means not. So it's not rational. Here I have some positive integers plus 0. So that means they're whole numbers. Here I only have positive integers, which means they're natural numbers. And here I have some positive integers plus some negative integers, so that means they're integers. Remember, that's a j, integers. Okay. Okay, so now, I know it's kind of silly, but you have to remember that natural numbers, whole numbers, and integers, if you think of them as sheep, the sheep are alive. They're all whole things. They're not cut into pieces. When you have rational numbers, sometimes they can be fractional. You can have parts of things, which is like dinner, okay? So rational numbers are things, fractions or decimals that repeat or stop and can be made into fractions. Irrational numbers go on forever and ever. And all the numbers we're doing in this course are real. So you can see here I have 5 sheep. That's a positive number. It's also a whole number because the whole numbers have positive. And here it's an integer. Okay. So it's a nice number. It doesn't go on forever and ever, so it's rational. And all the numbers are real. 3 over 4. If I think of a sheep that's 3 over 4, that's not an alive sheep. It's dead. It's dinner. Okay, so it's not these ones. And it's a fraction, which means it's going to be a rational number. And all the numbers we deal with are real. The square root of 4, that looks kind of crazy, but let's just check. The square root of 4 is 2. Oh, I'm tricking you. This is really 2. So 2 is a natural number, it's a whole number, and it's an integer. And can 2 be made into a fraction? Yep. So then it's also rational. And all the numbers we're using are real. Oh, that doesn't look nice. But let's just check because your teacher might be tricking you. Oh, it's really equal to -2. So, -2, well, there's no negative numbers here, so it's not natural. There's no negative numbers here, so it's not whole. Here's a negative number. Okay, so we know it's an integer. Can I make this into a fraction? Yep. Okay, it's rational. You can see it doesn't go on forever and ever, so it's not irrational. And it's a real number. Square root of 11. Let's check because your teacher might be tricking you. Oh no, it's a messy number. There's no repeating and it doesn't stop. And this is like less than 3.5 sheep, so this is more like dinner. It's not a live sheep, there's parts, so it's not any of these. It goes on forever and ever, so we know it's going to be irrational, and all the numbers we're dealing with are real. So 0 over 3, that's if I have a cake and I cut it into 3 pieces, and then in the morning I go to look at the cake and have some, but my brother's eaten it all. It means there are 0 pieces left, so I have 0 cake. So this is equal to 0. Is 0 in the natural numbers? No. 0's in whole. 0's in the integers. Can I make 0 a fraction? Yep. 0 over 3 or 0 over 1. So 0 is a rational number. It's a nice number. It's not something that goes on forever and ever. Okay, and all the numbers we deal with are real. 0.4 with this little hat on it. Let's see, what does that mean? It means this. It means keep pushing lots and lots and lots and lots of 4s in your calculator. And if I push equals, it changes it into a fraction. But this is less than half a sheep. So if I have less than half a sheep, the sheep is not alive, so it's not one of these. Okay? But something that repeats is going to be a rational number. And you can see my calculator turned it into a fraction for me. So anytime we have repeating things, they can be converted into fractions. And all the numbers we deal with are real. Pi. Let's check pi. Because oftentimes teachers will say pi is equal to 3.14. But that's only takriban, approximately. You can see that pi is equal to a big number that goes on forever and ever and ever and ever. So this is like 3 sheep and a bit. So we know it can't be any of these, because these are like whole sheep that are alive. Okay, and this is I have 3 and a bit. So this is more like dinner. Okay, so here it goes on forever and ever and ever. So it's going to be an irrational number. And all the numbers we deal with are real. And we can say that this is equal to a crazy number, crazy number, that goes on forever and ever and ever. Same like 11. Okay.